conditions. Uh, that's beyond where we want to go in this course. 229. The other book, I'm not quite sure what the page number is, and I'll check with Quinn, and she'll let me know. Odds are you're not going to spend all weekend reading it.
Yeah.
Odds are. I bet that most of you would not. So for that one book, 229, and I'll check on the other book. If we take the weather elements that we've discussed for the last 6.5 weeks, and we put them together, we end up with climatic patterns. Your textbook does a kind of a veneer job on the climatic patterns. I'm going to do a veneer job as well. We're not going into great detail. But when we look at these climatic patterns that we have across the globe, we could spend, and there are classes that spend all semester on this, analyzing the data. We're going to stick with the broad climatic patterns, the major climatic patterns. Now, we've been classifying climates for roughly 4,000 years. The Greeks did it early. They identified 3 climatic zones, the equatorial, the polar, and the mid-latitude. We've talked about those zones. Well, in the 1800s, late 1800s, early 1900s, people were beginning to be a little more serious about climatic conditions. And various techniques were developed to classify climates. Probably the best known system is a system called the Köppen, K-O-P-P-E-N. And if you look at it from the German perspective, it's Köppen. But it's spelled K-O-P-P-E-N, and most people refer to it as the Köppen system. Köppen looked at climates in relationships to vegetation. And he looked at basically tying the two together. So the climatic zones are also related to the biomes. Biomes are vegetational communities. So they're intertwined, as Köppen rationalized that the major factor determining vegetation would be climatic conditions. And it gave him an opportunity to do his classification in areas where there weren't a lot of people, but there were always plants. And he could look at the biomes and say, okay, this fits into this category, this series of plants will fit into that category. So if we look at the climatic zones up on the board, and we were to look at biomes or where various types of plants are, we'd see that they would match. They would almost perfectly match one to the other. Okay, so Köppen said, okay, there are 5 major vegetational zones. So now there are 5 major climatic zones. And he made it easy on you. He really did. The climatic zones are A, B, C, D, and E. And it's almost like 1, 2, 3, 4, 5. So they're pretty straightforward. A, B, C, D, and E. A, C, D, and E. A, C, D, and E are based on temperatures. B is based on precipitation, or the lack of precipitation, actually. And he starts at the equator, and he ends up near the poles, around the poles. So if you're starting with the alphabet at the equator, climatic conditions at the equator would be which letter, obviously? That's right, A. Okay, we have A climates that are the tropical climates. Okay, what's a tropical climate? A tropical climate is any climate where the coolest month, is above 64 degrees Fahrenheit. That's where the average temperature for the coolest month is above 64 degrees Fahrenheit. That basically means it's a frost-free zone. It's a frost-free zone. So if it's in the northern hemisphere, January must average over 64 degrees. So if we think of the U.S., basically just a little tip of Florida and Hawaii are the only two that would experience temperatures high enough to be classified as A climates. Well, then he skips down into a C category. These are climates that are in the mid-latitudes. And there are two mid-latitude climates, C and D. And one is referred to as mild winters, the other one is cold winters. And the distinction between these two is the coolest month is less than 64 degrees, but above 27. So the coolest month falls in the range of 27 to 64 degrees. Wausau fit into that? No way. Because the coolest month here is what? 18, 19 degrees. So what we're looking at is basically southern Illinois, St. Louis area down to the Gulf Coast. And so basically that dark green of the U.S. there would be where we'd see the sea climates. That's the only area where you'd have temperatures warm enough to fall into that range in the winter. Well then, if we don't fit into that category, obviously what's next for us? The D climates where the coolest month falls below 27 degrees. So the coolest month is dropping below 27. So our January temps or December temps fall into that. But there's another factor involved. The warmest month must be above 50. Coolest month below 27, warmest month above 50. Wausau fit into that?
Oh yeah.
Oh yeah, no problem. Then that's the blue, the pale blue as well as the dark blue on this particular map. And you'll notice basically the D climates are almost exclusively, not quite, but almost exclusively in the northern hemisphere. And the reason for that is your major land masses are at a high enough latitude for that to occur. In the southern hemisphere, you have very little land mass, much below 30 degrees south latitude. And so consequently, the idea of having these D climates not very common. Tip of South America will have some small areas of D climate, but basically, this is a northern phenomenon. This is the zone where you get the great temperature range. When we did the thermograms in Siberia, here we have that pale blue up there. That's a D climate. It's where you find D climates, you find the maximum temperature range. Okay, then above that, we see this off purple. Anyway, I think it's purple. Is it purple?
Like
Good.
lavender.
Okay, off purple, light and dark. This is the polar climates. These are the polar climates. And here temperatures never exceed, on a monthly average, 50 degrees. So every month, the average temperature drops below 50 degrees. So polar climates, you have no warm summer months. You may have high temps periodically, but they don't average 50 and above. So that's Köppen system, A, C, D, and E. And they correspond to vegetation. And if we look at the purple Greenland, center of Greenland up there, what vegetation would you expect to find up there? None. It's referred to as an ice cap. And then the darker around the edge, plus what you have in Canada and Alaska, this is tundra environment. And tundra is not only a climate, but it's a vegetational zone. The deep red we see along the equator on these islands, what do you think? What kind of vegetation? Rainforest, you bet. So again, the temperature, the climatic zone and